Hello everyone, welcome to Science Jagat. In this video, I will be introducing you to the world of nanotechnology. First, let us understand what is nano. Nanotechnology, as the name suggests, it comes from the word nano, and the word nano has been derived from the Greek word nanos, which means drop or small. 1 nanometer is equivalent to 1 billionth, that is 10 raised to the power minus 9 of a meter. But when we talk of nanotechnology is related to manufacturing of matter controlling the size in the dimensions of 1 to 100 nanometer. Now first let us understand what how can we compare macro, micro and nano scale. Now nano is um, it can be like a cellulose nanofibril, it can be a DNA which is in the range of 2 nanometers, a hydrogen atom that is zero point 0.1 nanometer. Now compared to this we have microscale which is can be like human hair which is 80,000 nanometer, smallest eye can see 10,000 nanometer, and the size of an E. coli bacteria is actually 2 nanometer. Comparing it to the macro scale, a person is 2 billion nanometer, an apple is 80 million nanometer, and an ant is 5 million nanometer. Now you can bring out the comparison how small is nano. We have important contribution of some famous scientists like Richard Feynman. He was a American scientist and he gave a famous lecture stating there is plenty of room at the bottom. With this lecture, he gave a vision of nanotechnology, meaning to say that when we move down to smaller scale, there is plenty of scope. He was a person who gave the vision that why cannot we write the entire 24 volumes of the Encyclopedia Britannica on the head of a pin. So he was a person who actually gave the vision of working on smaller scale. The next important contribution is of Tim Eric Dexler. He was an American scientist, engineer he was, and he gave the concept of molecular nanotechnology. He has discussed the concept of molecular nanotechnology in his book, Engines of Creation, The Coming Era of Nanotechnology. Yes, this is a man behind the term nanotechnology. He is Nario Tanguchi. He coined the term in 1974, the word nanotechnology. Now let us understand what nanotechnology actually means. In nanotechnology, what we are doing is we are designing nano products. Now, I say we are designing, what do I actually mean? By designing, we mean, for example, we are designing a nanoparticle that targets to cancer cell line. Now, that nanoparticle, first of all, it has to be synthesized. That nanoparticle will be synthesized and it will be made specific to target those cancer cell lines. So, by that, what will I do is, what I'm doing is, I'm designing. So, what I actually mean by designing is that I will be adding certain receptors to that nanoparticle, or I will be adding certain ligands or markers that will help me to target those cancer cells. Now, when we design nanoparticle, we need to see what is the dimensions. I discussed before, the particle has to be in the range of 1 to 100 nanometer. So, I need to check is the size of my nanoparticle, and as I will be discussing further in my slides, the size matters a lot. In, in fact, when we are making nanoparticles, even the properties of 2 nanometer particle and a 3 nanometer particle can differ very much. So, in case of nanotechnology, characterization is very important. Characterization is actually studying the nanoparticle, which can be done by advanced techniques like AFM, STM. Um, AFM is atomic force microscopy, STM is scanning tunneling microscopy. These are advanced form of microscopies that can help to see the structure atom by atom. So actually nanotechnology is all about atomic manipulation that I will be discussing in my further slides. So when we have designed, when we have studied our nanoparticle, and when its application is known, then we are going to produce them. We are going to produce them on higher scale. So when we are producing them on a higher scale, we are applying them to make structures, devices and systems. It's same as we have cell, we have tissue, then we have organ, and then that forms the organ system. So on the same lines, we have a nanoparticle, then we make it functional, then we add certain things to it that makes it more specific for the function that it has been designed, and then it forms a whole system, and this is controlled on with controlled manipulation of size and shape at the nanometer scale. At this nanometer scale, now we know it is 1 to 100 nanometers. So it produces structure, device and system. Of course, it needs to have a novel property or a superior characteristic and property which will make this particle unique, the system unique. So this is what nanotechnology is actually all about. Now, why we are moving towards nanotechnology? We had the micro scale, right? Then why is there need of making things at nanoscale? So you will, when I will be discussing my further lectures, in this we will be coming around the term miniaturization. What does miniaturization actually means? Miniaturization is moving towards miniature objects. Like we are moving down to nanoscale. Now, when we move down to nanoscale, there are many things, many properties that will change, and there will be enormous change in properties of particles. A very simple example I will give you in this. For example, we have dust, right? We have soil. Okay, we take it soil. Now, when the soil is uh, in the form of a stone, okay, that stone, if you throw that stone in desert, that will definitely fall down. Why? Because of the gravitational pull. Force of gravitation will be so strong that it will, if I throw a stone in air, that would definitely come down. But you must have observed when there is a wind blowing at high speed or in deserts, you will see the particles of dust suspended in all over. Now, those particles are only making that stone, but that stone cannot be suspended for a longer time in the environment. But those dust particles, they remain suspended for a longer period. Why it is so? Because those particles are comparatively very small. The gravitational pull is very compared to the stone. It is very small. So that's why the particles remain suspended. So you can make out how the properties change when we move from the microscale to the nanoscale. So we are doing mass production, it lowers the cost and it gives completely new functionalities when we move from micro to nanoscale. The completely new functionalities, these are gained by various phenomena, and we have completely new atomic structure and small volumes to ratio effect. Now what is the small volumes to ratio effect? We will be discussing this now. Now, surface area to volume ratio, it is also known as aspect ratio. This will show you how the dimensions actually make a difference. Now, when I talk about this, I mean to say, for example, you have this big cube. Now this big cube, this is of 2 mm length and 2 mm breadth, and the surface area is height into width into number of sides into number of cubes. So the surface area of this whole cube will be 2 into 2 is the length, 2 is the breadth, 6 are the number of sides, and 1 is the number of cube. So this makes out 24. But when I divide this cube into 8 cubes, the surface area now becomes of all these cubes becomes 48. Height is 1, width is 1, 6 number of sides of each cube into number of cubes is 8. So it becomes 48. However, the volume will remain same. How? Because the height, width, length into number of cubes. Here the height is 1, width is 1, length is 1, and number of cubes are 8. So it becomes 8. Now when I divide this surface area with the volume, I get 3 in case of larger cube. And when I divide this 48 with 8, I get 6. Now you can see how this surface area to volume ratio is actually increasing in case of particles getting smaller. The cubes are getting smaller in dimension, but the surface area to volume ratio is increasing. And this is known as aspect ratio. How does it make a difference? We will discuss this. Now we have this cube that is divided into smaller cubes. But when I divide this bigger cube into smaller cubes, what I get is exposure of these hidden surfaces. So the hidden surfaces are exposed when the larger cube is actually broken down into smaller cubes. Then how does it make a difference? Question is, how does it make a difference? Yes, it will make a difference. Why? Because it will provide an increased surface area for adsorption, for catalytic activity, and many such phenomena. So, when I reduce the size from micro to nano scale, there is increase in surface area. Now, for example, I'm designing a nanoparticle with, and I want to attach antibodies to it. And those antibodies, for example, I am designing a nanoparticle, I'm attaching certain antibodies to it, and I will be using for some tests like ELISA. Then in that case, I will have an increased surface area and more number of antibodies would be attached. Similarly, when I am doing targeted drug delivery, more amount of drug can be delivered to the actual site of action. Why? Because I will have increased surface area. Similarly, if I am designing enzymes which with catalytic activity as nanoparticle, there would be more sites on these enzymes for better catalytic activity. So this will enhance the activity. So coming to the unique properties of that nanotechnology gives me is the small dimension. No doubt the size is small, so dimensions would be small. This would enable high speed and high functional density, for example, lab on chip. For example, we have DNA microarrays. So DNA microarrays, the basic function is that the oligonucleotides are attaching with the sample. Now, when I have increased surface area, I would have more oligonucleotides immobilized on my chip and more number of samples would be detected at a same time. So this nanotechnology not only reduces the size of my uh, chip, it would be small, it would be lightweight and better sensors with high specificity and spatial surface effects. So we have large surface area which would increase the catalytic effect. We have, for example, high capacity for adsorption. For example, Pond's is making uh, face wash with activated charcoal. The concept behind it be like charcoal is a good adsorption, and when I have charcoal particles in my face wash, that would be taking out the dust particles on my face very easily and will provide a better product. Similarly, we can have, for example, we are doing filtration and the membrane is made up of nanoparticles. So there would be better filtration, better diffusion barrier. One more very important concept of nanotechnology is the quantum effect. When I will be discussing in my future lectures, I will be discussing with you quantum dots. Now, you must have heard this word quantum dots. Samsung is making LEDs with with the tag name of QLEDs. Now, these QLEDs have actually made up of these quantum dots with excellent quantum effects. The resolution of these LEDs are amazing. So this is again a gift of nanotechnology. We have new molecular structures with better strength. For example, in case of carbon nanotubes, the many things have been designed with the use of these carbon nanotubes, nanofibers and nanocomposites. So what actually happens at nanoscale is a better molecular interaction, better molecular labeling, better encapsulation. Encapsulation works in case of drugs which are actually harmful and they need to be delivered to the target site in encapsulated form. So these nanoparticles, I will be discussing structures of nanoparticles. These nanoparticles, they have core shell type structure. So when they immobilize that drug in the core, it becomes encapsulated and the shell carries the receptors or some ligands that attach to the target site, and then this shell structure opens and the drug is released. So nanotechnology holds the promise of delivering the drug safely to the target site. When I move from bulk material to the nano size, there are many properties that are improved. The surface area. In case, for example, I'm using a gold nanoparticle for catalytic activity, there is increased surface area and improved catalytic properties. Similarly, we have better antibacterial properties. If, for example, in case of silver nanoparticles, which are known for their antimicrobial activities, we have better hardness in case of nanocomposites. We can make efficient quantum effect particles with quantum effect like quantum dots, which are actually semiconductors, and they play their game on the concept of band gap energy. I will be making a new video on quantum dots. Then we have better electrical properties, magnetic properties, all because of the gift of nanoscale. There is enormous change in surface area when we move the particle from bulk to the nano size, and this is what actually is nanotechnology all about. This was all about introduction to nanotechnology. If you like this video and want to have notifications, please do like and subscribe. Visit us on www.sciencejagat.in. You can email us your queries or visit our Facebook page for further updates. Thank you. See you again.